Thanks to everyone for joining today. First, I'd like to thank our speakers and briefly introduce each one of them to you. Our first speaker will be Peter Jarek from Current Analysis. Peter is Vice President of Consumer and Infrastructure at Current Analysis, and he manages the firm's syndicated research into network operations and software solutions deployed at telecom service providers, along with consumer services, service innovations, and connected devices that all use those networks. Our second speaker will be Dan Teichman from Sonus Networks. Dan just joined Sonus earlier this year, and prior to that, he had worked with Empirix, a market leader for testing, monitoring, and analytics solutions, where he held multiple management positions for product marketing, product management, sales engineering, and professional services. And our third speaker is Chris Cave, who is joining us from InterDigital. Chris is Director of R&D at InterDigital Labs, where he leads the development of advanced wireless technologies and standardization for future cellular systems. Since joining InterDigital in 2001, Chris has held a variety of engineering and R&D management positions, focusing on the design and development of 3G, 4G, 5G, cellular, and also Wi-Fi systems. So everyone's excited to see the path to 5G. It's a huge topic in the industry right now, but depending on who you talk to, there's a varying perception on the timeline to deploy, the challenges to deploy, how much runway is left with LTE. So the question that we're hoping to answer for you today is the path to 5G going to be smooth sailing, or might there be speed bumps along the way as we work through remaining evolution of LTE and expansion of voice over LTE? So with that, I will turn it over to Peter.
Thanks, Claudia, and good morning to everyone. Thank you, everyone, for joining us. So, Claudia mentioned, my name is Peter Jarek, and for those of you who don't know what Current Analysis does, I won't take too long going into it, but we're a market intelligence firm focused broadly on really competitive positioning, tactical issues in the telecom and IT world, really supporting the sales enablement side of the market, helping vendors and operators know where they're competing in the market, how they're competing, and really how they fit into the telecom landscape and the IT landscape. And obviously, 5G and 4.5G are huge topics on that front. So I'm really excited to be talking to you guys a bit today about that. So we can go on to the next slide. We'll dig into the content side, not just the marketing of what we do. So, any question about where we are with 5G and are we going to have smooth sailing has to begin with the question of really, well, what is 5G, right? And the problem really is we can come up with a great literal interpretation, right? We know that it's sort of whatever is coming next. It's going to involve things like more data to more people. You see usually 10 or 1,000-fold increases in general performance, and you see that sort of in the chart here of what's being talked about in terms of IMT 2020 and the ITU designation of what will be thought of as 5G versus IMT Advanced, which is really 4G. So we kind of know literally what it's going to be, and from a technical standpoint, I think we also understand what's going to go into the technology to make that happen. And I think we'll hear a little bit more later about the technical side of things. But it's probably going to include use of new spectrum, new antenna structures, integration of multiple technologies, licensed, unlicensed, probably backwards generations, and of course a lot of virtualization. But that's sort of the easy side of things. And if we want to take the literal definition and get the basics, it gets a little bit tougher as we move along. So if we go on to the next slide, I think the reason why it gets tougher is it depends on who you talk to about what 5G is, because one, it's still getting defined, and there's a lot at stake here, right? So the big picture is that it's a work in progress. Yes, we're talking about today commercialization. First commercialization isn't expected till 2020, with really mainstream commercialization obviously coming several to many years after that. But in the meantime, we've got a lot of different vendors who are all trying to either sell their visions or sell their intellectual property, if you want to be a little bit cynical there, and and they're trying to say, hey, well, here's what's going to go into it. And so we've got all these competing definitions out there. And when I say though that there's a lot at stake, yes, there's a lot at stake in terms of the money being made by those guys, but the promises are pretty huge, right? Because the promise at its basic level, and we talked a bit about that, and we have a neat chart here from the 5G PPP, is that really the big picture here, the value prop is going to be this perception of unlimited bandwidth, unlimited use cases to sort of every user group that's out there. And we jumped into the next slide, which is fine. And you sort of see that here. The question is sort of how are we going to do that, right? And this really gets into, I think, some of the core of what is going on in terms of some of the confusion in terms of maybe what 5G is. Right? And I say that because to date it's been pretty easy, right? With 2G to 3G, we knew the value prop. It was more data. With the move from 3G to 4G, again, we knew the value prop. It was more data. As we move from 4G to 5G, it's not just more data, right? It's more everything, right? We're going to want to support high bandwidth and low bandwidth use cases. We're going to want to support low frequency and high frequency spectrum. Yes, we're going to want low latency communications. You see that as a big value prop. You hear that oftentimes brought out. But there'll be use cases that latency won't be that important for them. We'll need to figure out how to accommodate those in the air interface and the technology. Yes, we're going to want more users, but we're also going to want that with more reliability and reaching out to more constituencies. And I like this chart from the European Commission because it kind of captures that, right? It captures the idea that we're trying to hit mobile broadband use cases, mission critical ones, and some sort of massive IoT. But to do that, you're talking about multiple dimensions, which is very different than the single dimension of more data that we've had in the past. But it's more than just this. So we go on to the next slide. I think the other reason why we're talking a lot about this is that, although I mentioned before that 2020 is when, people generally expect to see initial commercialization, it's going to happen sooner than you think. And I say that because 5G is becoming sort of part of a national agenda, right? Where you see countries, you see constituencies who are saying, look, we're going to be out there early. We're going to show what took place. We're going to show that we're a technology leader. And some of this, I think, you're feeling from the World Cup, years ago when it was back and forth between Japan and Korea, and Korea really used that occasion to say, hey, look at all the technological advances we've made, right? Outfitted their stadiums with all sorts of flat panels, great screens. Everyone's like, wow, these guys really have it going on. And Tokyo felt a little bit, Japan rather felt a little bit behind. And I think what you see here is 5G is being put out there as something that you're going to see initial deployments, trials, pre-commercial, call them what you want. You're going to see it in Tokyo in 2020. I think we know that. But before that, you're going to see it in Korea in 2018, and probably before that, you're going to see it in Russia in 2018 for the World Cup. And so we're going to start to see this stuff in just a few years. But that means then that the prep work has to start getting underway right now. And some of it is, right? We're seeing virtualization. We're seeing the use of unlicensed spectrum. We're seeing work around LTE for machine type communications, LTE with I would say massive carrier aggregation, but we're already seeing 3CA carrier aggregation and lots of small cells. And what that really points to is part of the reason why 5G is important now is because we're getting ready for it, and we're getting ready for it sort of under this rubric of what would be called 4.5G. So I'm just going to take a minute or two to talk a bit about what 4.5G is, or what it could be, or what we think it is. And one of the fun things is you can think about it is that for good or bad, there's already some battles around branding about, is it 4.5G, is it pre-5G? So with apologies to the folks in the 4.5G camp, I love you guys, but I just used pre-5G here for a placeholder. And and if you're asking sort of what is pre-5G, what is 4.5G? It's exactly what it sounds like, right? It's this bridge between today's 4G, today's LTE networks, and tomorrow's 5G. So whatever's coming between LTE Advanced and 5G. Technically it's going to be, probably part of the 4G standards, and technically it's going to probably include 3GPP release 12 and release 13 standards, though clearly as those releases go forward, they'll always include things that matter going backwards. Technological highlight, We're going to be talking about a lot of the same things that we talked about in terms of 5G, new spectrum usage, right? How do we use unlicensed spectrum? How do we maybe use some different bands? New antenna usage. Massive MIMO is a big part of what we're seeing in terms of some of the stories for pre-5G. Multi-technology integration, again, thinking about unlicensed in particular, but also in terms of massive small cells. I think some of the early stories we see are in terms of how you're scaling it from a small cell side of things. And really almost everything that you hear in terms of 5G, probably with the exception of a new interface, which people are sort of, I don't want to say putting off, but there's questions around. And two of the big vendors that are pushing this include Huawei and ZTE, and there's a little slide here from ZTE, and it really talks about this idea that looking at key principles of 5G, but leveraging it before 2020 and leveraging the existing air interface. And it's kind of as simple as that. Of course, it'd be nice if it were really as simple as that. So there are a couple of things to think about. If we go to the next slide, I can finish up with some of those thoughts. One of the things that the whole concept of pre-5G really highlights is that really the idea that 5G is still many years away. Again, commercialization, yes, we're going to see pre-commercial trials. Yes, we're going to see some movement in the next couple of years. But we know commercialization, taking this mainstream is going to take a while. In the meantime, no vendor really wants operators sort of stopping their investment or going, I'm okay for now, right? That I'm really okay to sort of sit and wait to see what takes place. Maybe I'm not going to invest as much in my networks, right? There's still a lot that needs to take place in those networks to support new services, to ramp existing services. And so operators need to keep investing in their networks. Vendors need to keep selling gear. And so to some extent, this whole concept of 4.5G really is more important than anything, because it's what's going to be that bridge and keep investment taking place, right? And you even see folks, although I talked about the Chinese vendors really driving this, you even see discussions from folks like Alcatel-Lucent saying, look, here's what we can do, right? Combining carriers, combining sites, really leveraging things like VoLTE, combining carrier with wireless LAN. If you think about it that way, the real key here is that this concept of 4.5G or pre-5G is really a stepping stone to 5G, right? This idea that we can get comfortable with some key 5G capabilities, but more than that, that the investments today set the stage for those 5G services, whether it's investments in figuring out what we're doing with licensed spectrum, whether it's investments in understanding small cells and building those strategies, whether it's virtualization, right? That's going to set the stage for what takes place next. And that's probably what, if we think 5G is going to be probably one of the most important wireless technologies by addressing so many use cases, that's what makes 4.5G really important in the here and now. So with that, I'll turn it back over to Claudia.
Great, thank you, Peter. Right now there aren't any questions specific to your slides, so I'm going to keep going and hand it over to Dan. Dan, are you ready?
Sure. Thanks, Claudia. Thanks,
Great.
Peter, for that introduction. So I'm going to talk a bit about voice over LTE. It's something that Peter didn't touch on, but I think it fits into the profile of what he was discussing and where things are headed. So real quick, I'll touch on who we are, the business case for VoLTE, timing and status, where we are, and more importantly, the challenges we've got and solutions. So who is Sonus? Sonus is a company with a history of innovation and disruptive technologies for both service providers and enterprise customers. We've started in the voice over IP business, and we've moved along. We're really focused on real-time communications and real-time communications at scale, and how we help our customers deliver those services. And as of the beginning of this year, we've also acquired a company which allows us to move into the software-defined networking space, and there's really a place where that's going to play as we evolve from where we are today to 4.5G and 5G, as Peter said. So with that, let me move on and talk specifically about the business case for VoLTE. So let's start with increased customer satisfaction. There's a real expectation that customer satisfaction is going to go up, especially for voice services, because of faster call setup, more reliable handovers, high-definition voice codecs. Essentially, there is an expectation and therefore a promise to deliver, and I'll touch on this later on, of better service as you move forward with VoLTE. That's better than 3G. And then we'll talk a bit later about where that's going to go with 5G. Move on. The other thing that I really want to touch on for customer satisfaction is today on my phone, I have 4G on my phone for data, but I still use 3G for voice. With VoLTE and the native solution to have voice over LTE running over the same infrastructure as my data, I now will be able to use voice, video, and all my data applications concurrently on my handset. That means I get a better experience, and ultimately what we're going to see is people are going to build apps that allow you to combine different technologies that couldn't be combined or different services that couldn't be combined previously. Move on. The other big business case driver is around operators reducing their costs, being more efficient. Fundamentally, it just will cost them less to carry the traffic when everything is IP-based. Fundamentally, it'll cost them less total cost of ownership when they only have a single network to manage for voice and data. Now, we're not there yet today, but there's clearly parts of operators' networks where we're going in that direction. And for them, that's a huge driver going forward. And the last point I want to make on this slide is we will clearly see, it's already begun, that operators will be able, as they roll out VoLTE, to go back and reclaim or refarm some of that 3G spectrum and allow them to put further LTE traffic out there, because clearly we all know data is still driving the investments. But as Peter indicated, people are going to make additional new investments going forward. And what we're seeing is, hey, but wait a minute, I want to reuse what I've already got so I can be better prepared to go forward in the future. Because as we saw, if you get to 5G, there's going to be huge amounts of traffic, and people are going to have spectrum to handle that. So with that, let's move on and talk a little bit more about where we really are today with VoLTE. So the pie chart you see here was the results of a survey from Infinetics for how soon would people be deploying voice over LTE after they deployed LTE. And as you can see, the majority was in the 2 to 3 year time frame. So that leads us to kind of ask, well, where are we with commercial LTE, and therefore where are we with VoLTE? So where we are today is, you can see there's about 425 commercially deployed LTE networks, but only about 25 commercially launched VoLTE networks. That's only about 6%. Yet there's another 100 or plus operators who are in studies and trials and early deployment phases, and that really significantly raises the bar. And so I think what you're going to see is that we are well along the way, but still have a long way to go, especially as we enter the second half of this year and move forward. One more item on here, I think this is a really important point to make, is that there is no VoLTE without handsets or subscriber devices that are capable of supporting voice over LTE. We're now over several hundred devices. As that number ramps, that will be a significant driver to help move the acceleration forward for VoLTE deployments and clearly widespread VoLTE adoption. Okay, so we kind of know what it is and we know where we are. Let's talk a bit about the challenges, because VoLTE just doesn't just appear. There are some challenges to get it deployed. So the first one we'll talk about is security. So VoLTE is now running over an all IP network from handset to core network. So many of the same security concerns of any other IP network with regards to things like malicious attacks and preventing access by unauthorized users are going to be the same as we bring VoLTE in. And what we need to remember here is that the importance for security covers both the signaling when calls are set up, as well as the media protocols that are carrying the traffic itself, and they cover both the access domain from the subscriber side as well as the peer network interconnect side, because VoLTE as an island doesn't help. You've got to interconnect with other subscribers and with other networks to make the traffic work. Okay, so that's security. The next challenge is quality of experience. Again, as I mentioned earlier, there's a subscriber expectation, partly driven by the industry, who's telling people, hey, you're going to have a better experience with VoLTE. That means operators need to deliver on that. They need to deliver seamless, uninterrupted roaming. They need to make sure handovers work. They need to truly be able to deliver that higher voice quality with high-definition codecs. And finally, they need to support fundamental things like emergency calls. I mean, just everything needs to work, and it needs to work better. Of course, that's a challenge. It doesn't always happen that way. And finally, the third item here is scalability. So VoLTE is a high-volume transactional traffic. There are so many signaling messages exchanged even before a call is established. Roaming exacerbates that traffic. The fact is there's just a tremendous amount of traffic to be handled, let alone the media, and all that needs to be managed by the operators, who need to know that they're making investments in solutions that scale. And furthermore, they have to scale while also delivering that security and that quality of experience. I can't just say, well, sorry, if you want more security, you got to buy more devices. No, it's got to be able to scale, and scale inherently in the design of the architecture of what the operators are deploying. So these are some of the challenges we see for the operators to get VoLTE deployed. And again, many operators have already begun this, and some are well past this. As we saw, there are a number of commercial launches. So people are learning how to be successful at deploying VoLTE. And I'll explain here on the next slide some of those reasons why they were successful. So again, I'll touch on the same subject matter areas. So for security, people took what they knew and applied it into VoLTE. So SIP and diameter topology hiding, being able to ensure that nobody had unauthorized access to see things inside carriers' networks, because these are the protocols that are being used from the handset into the access, into the core, all the way up through the signaling and call control. So, and as I said, but those things have to scale, and they have to scale while handling things like encryption, and while being flexible and handling things like diameter screening on any message and any message type. The fact is that the security concerns have to be dealt with, and they have to be transparent to the end user. The end user needs to know nothing about this. Matter of fact, if there ever is security breaches, it's going to be real big and real visible. Quality of experience. So most operators are now adopting solutions that optimize the experience. They have to. They have to be able to identify, for example, roaming users and anchor the media. That means if you're roaming in a visiting network, to keep your media in that network rather than backhauling it to your home network before it gets terminated somewhere else. They have to find ways to make it more efficient. They have to be able to deliver call continuity, deliver calls between LTE or VoLTE devices and devices on non-LTE networks. They have to be able to deliver that across network boundaries. So the IMS infrastructure, the call control infrastructure for VoLTE, has defined how this should be done. People have to be deploying these IMS capabilities for access transfer, for handling emergency calls. Again, it's an investment they have to make. They have to get it right. They have to learn from their mistakes and be able to solve these problems and make that quality of experience what the end users are ultimately going to expect. And finally, scalability. Peter mentioned it briefly. There is no real solution that's going to scale over the long term for the mobile operators unless they're adopting network function virtualization. And we're hearing all the major mobile operators already telling the industry that's where we're going, that's what we expect you to deliver, that's how we expect to be able to scale for the signaling and media infrastructure we need to manage VoLTE. However, we also need to have a better radio access infrastructure. We need to be able to scale up and handle all this new traffic. And it's not the size of the bandwidth, it's just the number of people using more services. So things like densification and carrier aggregation, which have already begun as well. So these are some of the ways that people are solving the challenges to be able to scale VoLTE and move forward and drive that as another value-added service over LTE. So with that, let me move on to my last slide and basically give you my opinion of what's next for VoLTE. So clearly the next 2 years is going to be a big ramp. The second half of this year, 2016 into 2017, we're going to see more subscriber devices. We're going to see better radio access networks. We're going to see more deployments take place. And again, ultimately from an end user perspective, adoption rates are going to go up. Next. As I said, I think we're going to see innovative vendor solutions that are addressing these key deployment challenges. And finally, the adoption rates for VoLTE, I think, actually increase the value of the migration to 4G, especially around the reduced latency aspects, which are pretty significant for real-time communications. And ultimately, I think we're going to begin to see that, and maybe it's 2020, maybe it's well beyond, right? There will be a ubiquitous VoLTE capability set for everybody, and everybody's subscriber devices will handle it. It will become the new normal, just like for a large majority of the world, 3G is the new normal. And with that, I'll turn it back over to Claudia. Thanks.
Great, thank you, Dan. We did have a couple of questions. The first one that came in was related to the VoLTE challenges that you raised. And you brought this up yourself, that they have to first deploy IMS functionality in the network. And the question that came in is that there are many operators that don't have IMS yet, or are at a stage where they said it's going to be years before they can fully utilize it. Can you talk to that thought a little bit?
Well, there is a fundamental starting point, and that is that VoLTE is defined using IMS as its call and signaling infrastructure. I think, and I'm not sure where people are viewing IMS deployments. I think there are many operators who have actually made that investment in IMS, and I think you'd be surprised to know how long that's been going on for the past 7+, maybe 7 to 10 years even, where people started looking into it and deploying it. I think with things like network function virtualization, with some of the optimized ways of deploying the IMS core infrastructure, you're going to see a lot more IMS deployed if, as the question was asked, people aren't already there. And I just recently, as this morning, saw another research report that indicated significant growth in the second quarter of more voice over LTE and IMS investments. So I think that really is happening. I might push back and say more so than what the question was originally asked.
Okay, good. Okay, so we'll save the other question for Dan to the end, and we will go ahead and get started with Chris. Chris, it's all yours.
So thank you, Claudia, for the introduction earlier on and for inviting me to participate to this webinar. So before I get started, I'd like to introduce the company that I work for, InterDigital, to the audience. InterDigital is a research and development organization that's been innovating in the field of wireless communications for over 4 decades now. We were pioneers in the design of early commercial wireless systems and have since then significantly contributed to the design of 2G, 3G, 4G wireless networks. The company is headquartered in the US, where it also has 3 of its R&D centers, and we also have a strong international presence with R&D locations in Canada, the UK, and South Korea. Okay, next slide, please. Okay, so the previous speakers provided great overviews of sort of pre-5G and 5G and voice over LTE, and now I'd like to contribute to the discussion today by sharing our view of what 5G could be right as we're in the middle of designing it. So let's start off with the use cases. There's a number of academic and industry forums that have started to identify multiple use cases for 5G. 5G will clearly differentiate itself from previous generations just by the broad range of use cases and requirements that are expected to be supported, and you can see this on the left-hand side of the slides. In contrast to previous generations, where there was more of a focus on providing voice and/or mobile broadband services, 5G will include pretty much everything that you can imagine that could benefit from having a wireless connection. Okay, so that sort of makes the whole design somewhat more complex, just with a broad range of requirements and use cases. And so in our approach, we've tried to simplify things a little by defining 2 big use case groups, which you see on the right-hand side. The first one is 5G mobile broadband, which really includes higher performance targets across the board relative to 4G in order to meet the higher capacity demands for indoor and hotspot deployments. The second group covers just about everything else, or the Internet of Everything, and this group is really characterized by a diverging set of requirements that we believe 5G systems need to be designed to have native support for. Okay. Next slide, please. The next thing to consider for 5G is spectrum, where I'd say it's generally understood that new spectrum will be required in order to meet the anticipated demands for 5G. And here again, we're going to try to simplify things by looking at spectrum in two parts, above 6 gigahertz and below 6 gigahertz. So if we start with the top half, above 6 gigahertz, there's really an opportunity here to identify and use large chunks of spectrums in centimeter wave and millimeter wave bands. However, the spectrum here does have its challenges, and it has very different propagation characteristics compared to the lower frequency bands that we're used to dealing with in typical cellular systems. Okay. That being said, we do see a significant opportunity here above 6 gigahertz and believe that this spectrum is ideally suited for the ultra-mobile broadband use case for indoor and hotspots, and believe that there's a good opportunity to design a new radio interface here to support that. Now, if we look at the bottom half, we see two opportunities for 5G below 6 gigahertz. The first is new spectrum that could be identified for IMT service, and that opens the door for a new radio air interface below 6 gigahertz. On the second hand, we also believe that existing LTE spectrum will continue to be used and evolve towards 5Gs as operators want to leverage the significant investments that they've made so far in their networks. So for both of these cases below 6 gigahertz, we see this spectrum as being better suited for the Internet of Everything use case, along with providing some enhanced mobile broadband access. Next slide, please. So another key differentiator for 5G is that it will likely consist of many radio access technologies rather than a single one, as we have introduced in the previous slide when discussing spectrum. So 5G should be designed with built-in support for multiple radio layers that can operate either as standalone layers or in combinations with each other. Having these different radio layers really gives flexibility to operators in their early 5G deployments to adopt whichever layers they need based on their individual rollout plans. In the long term, we believe that most 5G networks will include all of these layers working together in concert. And in the next few slides, what I'm going to do is I'm going to walk you through each one of these layers to give you an overview of what we see how we perceive them. Okay? So next slide, please. So the first radio technology that we'll discuss now is 5G LTE evolution. And I think in the first presentation, there was some discussion about pre-5G or 4.5G and how that continues into 5G and our vision, and I think a vision that seems pretty consistent with a lot of other industry players, is that LTE will continue to evolve and be one of the key components of 5G networks. There's already a number of enhancements to LTE systems that are currently being standardized in 3GPP, and we expect quite a few more to come in the next few years, all the way towards 2020. So on this slide here, we show a number of features that are on the table for release 14 and beyond, and I'd like to emphasize a few of these. One of them is license-assisted access, which is starting in release 13, but we'll go well beyond that in release 14 and 15 with further enhancements. And this is a feature that enables LTE to operate in unlicensed spectrum. This is an opportunity to provide really significant capacity boosts to meet growing data needs. If we jump down towards the bottom of the slide, we have device-to-device communication, and this is a feature that really changes the way traditional cellular networks operate. Basically, devices that are in proximity of each other can start communicating directly without going through the network. And this, in turn, really enables a number of interesting applications like V2X for LTE, which you see on the left-hand side. And V2X is interesting because it enables car-to-car safety and traffic management applications, and it's a completely new area for wireless operators to provide service for. So these features that I've discussed and that you see in this slide, along with more that we expect to be introduced all the way through 2020, are what we think is going to keep LTE competitive and ensure that it is a key component of 5G networks. Next slide, please. So the next radio technology or radio layer that I want to talk about is what we have called 5G flexible access. So this is a new radio interface for new spectrum below 6 gigahertz which, as the name indicates, is built with a lot of flexibility to support many services having different requirements. Now, the main reason why we need this flexibility is to ensure that the spectrum resources can be used by multiple services. You absolutely do not want to need to dedicate spectrum to any one service type. Operators want to make sure that they can dynamically switch from one service to another as demand varies over time. And we have identified 3 distinct operating modes so far for this flexible access, but we could envision more in the future as well. So the first one, which is listed on the left-hand side here, is what we call enhanced mobile broadband access. And the idea here is to provide improved performance over existing LTE networks, smartphone traffic, voice over LTE, and so on. The next operating mode, which is shown in the middle, is targeting low cost and low power devices. This one here is characterized by a very large number of connected devices that typically have lower data rates. And then on the complete right-hand side, you see the last operating mode that we've identified as an initial mode for flexible access is this ultra reliable and ultra low latency mode. And this is what's going to enable new applications for 5G, such as remote control of machines and autonomous driving. Okay, so again, one of the key aspects of this flexible access is that it has built-in support for all of these operating modes, and one of the challenges here is to make sure that we can build a radio air interface that is good for supporting all of these diverging requirements. Moving on to the next slide, please. So the last radio technology that we want to discuss is what we've called 5G ultra mobile broadband access. And this is what we see as a new radio air interface above 6 gigahertz. So this is the radio in higher frequencies, essentially, where we hope to achieve the very high performance targets, and where we're increasing peak user throughput by an order of magnitude compared to what we have today in LTE. So one of the key enabling characteristics here, technologies for higher frequencies, is what we call massive antenna arrays. So because of the higher frequencies, we can actually design very small antenna systems that fit on single device. And that essentially helps us overcome the larger transmission losses that we experience at those frequencies. Another key enabling aspect of this ultra mobile broadband above 6 gigahertz is the much larger bandwidths that are available in these frequencies. And this is really what is driving the significant increases in data rates. Okay. Next slide, which is my last slide. So the final question here then would be to ask, when do we actually expect 5G to happen? And so to answer this question, I think we need to take a look at how the standardization of 5G happens. So in the first presentation, there was some discussion about the ITU that was introduced. So at the ITU level, they're in the process of defining what is called IMT 2020. And as part of this, they've already identified a target date of early 2020 for completion of specifications that would be considered for 5G. So what that means is that the organizations who are actually defining the specs, like 3GPP, well, they'll need to have their specs done by then, by end of 2019, early 2020. Now, within the 3GPP community, we've already started discussing the timeline, and we expect some initial studies for 5G to actually take place in the last quarter of this year, and that will run all the way through the end of 2019. Now, in terms of deployment, once the specs are done, we anticipate that 5G technologies will likely be deployed in phases, with initial deployment started in early 2020 until we reach really more mature 5G deployments in 2025. And until then, we have enhancements to LTE that also are expected to be deployed to meet the service requirements as they increase over time. And with that, I will conclude my presentation. Thank you.
Great, thank you so much, Chris. And I actually have a question for you that's come in from the audience. And one of your earlier slides, you showed voice as a separate service. And the question came in as to why voice is being considered a separate service going forward in the 5G world, and it wouldn't be just like any other data-centric application at that time.
Could you be specific on the slide? where we say voice is, I think when we referred, I mentioned voice when I talked about 2G, 3G, and 4G.
Yeah, I will back up. It came in during one
And
of your very early slides. This one, I believe.
right, I agree with. I think the voice service itself is, as we're going in the future, especially with VoLTE, is just another data service. It should be perceived as another data service that has a specific set of QoS requirements, but it's definitely part of the mobile broadband use case that we see evolving towards 5G. And I hope that answers the comment or the question.
Okay, good. And another question that came in, and I think I'm going to open this one up to all three of you. The question came in related to vehicle to X and vehicle to infrastructure, so car to car, car to infrastructure. And what about 5G, LTE, and then 802.11p? How do you see all of those technologies playing a role in this or not? Chris,
Okay, well,
go first?
yeah, I can take a stab at that. So maybe if we look at it from a timeline perspective, starting off with 802.11p or what's known as DSRC in the U.S. So I would say that is probably the technology that is readily available today, that has been designed and I think will probably get a head start in terms of deployment, especially in North America, where we're seeing some automotive manufacturers trialing DSRC as a V2X technology and are committed to including it in their vehicles by 2017 or 2018. The thing with the DSRC, though, is I think there's a general consensus that although it's a good technology, it might not be able to, on its own, meet the full demands of V2X for safety applications and traffic management, especially as we scale to a very large number of vehicles on the road. And so that's where LTE V2X comes in to complement it. And so I think there's one of the things we're seeing, for example, in 3GPP now is there's some automotive manufacturers that are starting to participate in 3GPP as they see the need to actually come up with an alternate solution to complement DSRC or 802.11p. So I think you know, in terms of deployment, you have DSRC, which is the initial case. I think you're going to see V2X over LTE, which is going to be standardized in release 14. That could be the follow-up technology to be used for sort of V2X traffic safety or car safety applications. And then when it comes to 5G, I think is when we get into some of the ultra reliable, ultra low latency features that could be associated with autonomous driving, for example, right? Longer term, but we will need a new radio air interface to support those features, because at this point we don't think that we can sort of build them into LTE and especially not into DSRC. So we would need a new radio for that.
Okay. Great. Peter, from the analyst perspective, what are your thoughts on this topic? What are you seeing?
Yeah, I think you know, I think Chris kind of hit it as this basic idea. I mean, if you take a step back, right, it's this idea that if you look at it, I mean, what you kind of, sorry about that, my phone just dropped. I think it's the basic concept of, you know, the value of LTE that you get in terms of where you can control things a little bit more closely, right? Where you can have that low latency and where particularly operators feel there's some tight requirements on there. And so it is the question of, hey, what can we do today versus in an ideal situation, what can we do going forward? And so I think Chris hit that sort of, we've got what we've got now, but going forward, if we're looking to hit specific requirements in terms of latency, in terms of reliability, et cetera, then there's opportunities to sort of take that forward. And of course, the 3GPP is going to figure out what they can do to fit in that to make themselves more valuable. So yeah, no, I completely agree with what Chris said.
Okay. Dan, I'm not sure if this is your area to add something. Is there anything you want to add? Dan, I think you're muted.
Apologize for that. I was saying I think the answers provided are probably more valuable than anything I will add on this particular subject.
Okay, no worries, but I have a question specifically for you, so why don't I jump to that one. So a question came in about your opinion or your view, what are you seeing related to any discontinuity issues with running hybrid LTE and VoLTE networks over the same spectrum? Is there anything you can talk to on that topic?
Well, interestingly enough, if Chris is okay, I'd actually like his opinion on this, seeing as he's got a lot more experience on the spectrum side, if that's really where the question was headed. I mean, from an operator perspective, I'm not sure why there'd be a discontinuity with trying to manage traffic that's both LTE data and voice over LTE over the same spectrum. But Chris, do you have any insight on that?
No, I'm not sure I fully understood the question itself. I think, but I think you're right in that from an LTE point of view, voice over LTE is just another service with a different set of sort of QoS requirements, right? So, and that can be taken into account in sort of the base station scheduling to make sure that higher priority traffic can get through faster and so on. And so I don't believe that it's such a big challenge to have a mix of both pure data and voice over IP traffic over the same data networks.
And just to wrap that up, I mean, that absolutely is the expectation, that there will be both sets of traffic running, and I don't think it's a spectrum issue at all. At least it shouldn't be.
Yeah, I think actually VoLTE, I mean, it's a technology that was late to be commercialized compared to LTE, but it actually provides a much more seamless and more efficient way of carrying voice traffic, because to date, without VoLTE, LTE networks have to rely on what's called circuit switch fallback, which is falling back to the 3G spectrum to place a voice call. And that, from a sort of a delay point of view and even a traffic efficiency point of view, is not as good as using VoLTE.
Okay, thank you. I have a 5G question that came in, which I think is great and really reinforces the fact that the industry needs to really define what 5G is. And the question is that doesn't it seem like 5G is doing too much, kind of trying to be an all things to all people type of solution, low latency, higher latency, or latency agnostic, high data rates, low data rates, et cetera, et cetera. So the question is it really possible to do all this, or does it make sense to have more focused technologies for different solutions? So I think it would be great to maybe add a little more background on what 5G is trying to accomplish here. Chris, you want to go first?
Yeah, sure. So I think that's a very interesting question, right? When you look at that first slide that I presented, the number of use cases is actually overwhelming for 5G. And the problem with the 5G use cases that I mentioned is they actually do have diverging requirements. Now, the one solution would be to define a different technology to support each one of those specific use cases, right? But then there is some inefficiency there in terms of having dedicated spectrum for each one of those technologies, and losing some scale in the market as well in terms of coming up with one overall umbrella technology. I believe going forward, though, there is a possibility for us to design all of this so that it works together in a sort of nice and efficient manner, and that's what we've been trying to do at InterDigital with this flexible radio access, is to come up with a framework where we're able to easily multiplex the different services in the same spectrum, right? And the key there is being able to multiplex the services in the same spectrum. Spectrum is a very expensive resource for operators, and they do not want to waste any of it. And so being able to use the same spectrum dynamically for different services is quite valuable for them, I believe. And just another thing is, I think we talked a bit about deployment of 5G services, right? And it happening in phases. Our view is that each operator will have its own rollout plan. We'll have to have different priorities up front. In some cases, operators may want to have this ultra-mobile broadband for the Tokyo games, for the Korean games. And in other markets, we're seeing the IoT as being, or IoE as being, more important for 2020. And so the idea is to provide a toolbox for 3GPP operators to deploy the services they want based on their own rollout plans.
Okay. Peter, do you have anything to add on this one?
Yeah. I was going to say, I wonder also if this is, I wonder if this is being sort of seen as something that is, if it's seen as different than it is, to the extent that if you look at, and I'm trying to figure out the best way to put this, but it was wrong as much as I said that, and I simplified things saying that like 2G to 3G was about more data, 3G to 4G was about more data, right? That that was clearly a simplification, because behind the scenes, right, with every standards evolution, there are a million different things going on to improve different aspects of the technology, right? And so, yes, we're not just talking about more data here with 4G to 5G. There's a lot going on, but I think that to some extent it's just we're being clearer about that, about how those different aspects of the technology impact different use cases, impact different constituencies. So, one, I think there's really just no other option, right? If we want the mobile networks to become more valuable, if we want mobile operators to play on a bigger stage and support, more use cases, you kind of have to look at having 5G be everything to everyone. But I also think it probably seems like it's a bigger deal and like it's trying to stretch more than in the past, just because it's more visible. So it's probably not as bad as it seems.
If I can just add to another point as well, just looking at historically the way 4G was designed, right? 4G was designed really for the purpose of mobile broadband as a sort of a fat data pipe, and since then, the overall the wireless community has tried to patch up LTE, I would say, or build in new functionality into LTE to try to support a broader range of use cases. So VoLTE is an example, right? It actually took VoLTE, there's a reason why it took VoLTE longer to be deployed than the basic LTE systems. If you look at LTE evolution, there's a lot of services for what we're calling LTE-M or low-cost MTC being introduced now, LTE for V2X, and so all of these enhancements are more difficult to sort of design after the fact than doing it ahead of time and building them into the next generation system. So I think we have an opportunity with 5G to sort of almost make it future-proof towards new services.
Dan, anything from your side?
No, I think that's pretty well been covered.
Okay, one interesting comment that came in, which I have to agree with this comment, would love to hear all of your thoughts too. During the research for the companion feature report, which is available with this webinar, one of the theories that I thought about was, is the industry going too fast? Are we talking about 5G too soon? Maybe have we thrown out the LTE and the VoLTE conversation too fast? And this is a comment that came in from the audience, which is, if 5G is triggered by limitations of 4G or LTE or VoLTE, have we even explored those technologies fully at this point to know what they're capable of, to say that we need to go to the next one? So, I mean, just kind of a quick around the panelists. I mean, do you agree with that concern, or do you think we're ready to be on the 5G bandwagon?
Let me actually jump in here first. I'm sure we all have some good comments from this. One of the things I think that's really important, the industry, and I collectively will call it all the operators, they're learning as they go. They're deploying things, they're running into challenges, they're finding solutions, and clearly not every solution that they needed was being solved by 4G for obviously a tremendous number of use cases on the data side. And we've talked certainly about some of the advances, and we'll hear more on the vehicle side, on the IoT side. I think from my perspective, what we've seen on the voice side, we still have a ways to go to move up the VoLTE learning curve and find the things that 5G will solve, but clearly one of them will be dealing with low latency or very low latency. So I think there's some advantages that I foresee going forward where 4G won't solve those problems, but I think it's clearly much more in the use case model around the explosive volume, if you will, of traffic and data services that are going to be out there. So I do think that 4G will, it's already known. I kind of say it's already known it won't solve every problem in its current infrastructure, current specifications, and that's why we're already looking forward.
Great. Peter, Chris, who wants to go next?
Yeah, I guess it's the question. Oh, shoot, Chris, go on. You're good.
Okay, so I would say, I think, you know, to the question, is 5G coming too early? Have we exhausted 4G? I think it really, the way I see 5G is it's really driven by sort of a business need for 5G, right? So, and we try to take the two use case groups that I alluded to earlier and treat them individually. If you look at the mobile broadband, right, that case there, we know one of the business drivers there is really sort of marketing, as you see with, I think, in Peter's slide where he's talking about the Tokyo Olympic Games, the World Cup in Russia. In 2020, will LTE networks be out of capacity where we need this ultra broadband? That's an open question. But we know that there is a need from a marketing standpoint to show those data rates. If we look at the other use case, though, this Internet of Everything, I think there is a significant desire by operators to really diversify their business models and really attack new verticals with wireless communication. They're in a position where, as owners of spectrum and network equipment, that they can really run out and make more money, increase their revenues by providing service to all these new vertical industries. And I think that is a big business driver for 5G, actually. I think that's sort of a new operator. There's a lot of these services that just won't work efficiently on LTE, and that's sort of the motivation to design a 5G network, at least for that second use case.
Okay, Peter, last comment, and then we're going to be out of time.
I guess I would add, you know, if you start with the question of, you know, should we be jumping on the LTE bandwagon or the 5G bandwagon this early? And I guess the question is who's jumping on that bandwagon, right? It's yes, there've been a couple of misguided operators that said they're going to deploy 5G in the next year or so, or jump 4G and go right to 5G and do it soon, and maybe they think it's coming quicker than it is. But largely, you know, I think it's been driven by vendors who are trying to get out there. Here are the opportunities. Here are the options, right? Here's what we should be thinking about. Here's what it could look like. And so, you know, right now, the 5G bandwagon is mostly, let's get prepared for what this is going to look like 5 years from now, right? And what it could be. And let's not forget that the investment cycles, right? That, you know, the investment cycles for mobile networks still include 2G. Right, still include 3G. So we're still seeing investments in those. And that's not to say that we don't need 5G. It's to say that those investment cycles run a long, long time. So yeah, we're going to see the investment cycle, and we're going to see that continuing investment in LTE for a long time. And recognizing that these things, you know, last for many, many years, then we need to start thinking early about 5G. And it's not to say that anyone thinks they're going to make the jump tomorrow. And yes, we know that we're going to see a couple operators that want to pat themselves on the back and deploy some early stuff. But if the goal is to develop something that we think will take us from 2020 to 2040, right? We'll still be around in 2035, 2040 if these things have, you know, that kind of lifespan. Then we need to start thinking early about this to make sure that we do it right and prepare for use cases we haven't even thought about. So no, I don't think it's too early.